Great. So, hi everybody. I know that I'm just in between you and the summary talk of this very interesting conference. So I will try to go straight to the point and in presenting you MOSAIC, that is the multi-object spectrograph for the ESO extremely large telescope. I'm speaking on behalf of the MOSAIC Consortium, of the MOSAIC Project Office, and in my recent role of PI of this instrument. So, the extremely large telescopes are now becoming a reality. ESO started the construction phase of the ELT, and the first technical light for the ELT is actually planned by the end of 2026. So, the ELT will be equipped with various instruments that among them we will have Mikado, the high optical quality enabled by the 5-mirror telescope design of the ELT, and also will be the only instrument, with the highest survey speed. So here you just can see the ELT instrumentation roadmap and the timeline. You can see that the Mikado, Harmony, and Metis will soon go to their FDR, with Maori instead moving to its PDR right now, and IRIS and the MOSAIC will instead enter, that are the second generation instrument, will actually have entering in phase B by 2021. So, but what is MOSAIC? So, as I mentioned before, MOSAIC is the multi-object spectrograph for the ELT, but is an extremely modular instrument which will able to deliver 3 different observing modes from the visible up to the H band. So, which are these observing modes? So we will have 2 multi-object spectrograph between 0.45 up to 0.8 micron, and another one in the near infrared up to 1.8 micron, with a multiplex of 200 sources. So that will observe both in low resolution and high resolution mode. We will also have an integral field units mode that consists of a maximum of 8 IFU integral field units with a field of view of 2.5 arc seconds, resolution of 150 mass, and as I mentioned before, this will be the integral field units will only be in the near infrared. So, as you can see, MOSAIC will be able to combine the advantage of a highly multiplexed instrument, able to target numerous unresolved sources in its MOS mode, with a more modest multiplex mode that, on the other hand, will be able to resolve faint sources specially, that is the multi-integral field units. So here you just have the mechanical design of MOSAIC after phase A. I might say that MOSAIC changed what you can see here, but it remains a big beast of 40 tons with a dimension of 10 meters by 7 and by 8 meters high. So it's really a huge instrument that will be placed probably on the second prefocal station of the ELT. You can see here the infrared spectrograph that now are moons-like spectrograph, the visible ones, and structure. So, but the important aspect of MOSAIC is that it will be a multitasker instrument for the ELT. What does it mean? It means that it will exploit the large field of view and collective power of the ELT, but will also provide strong synergies with future facilities. So we received recently the the feedback from the JWST TAC. So MOSAIC will be able to observe, to follow JWST sources. Then there will be strong synergy with the WFIRST, with LUVOIR, and with many other instruments, of course. It will also complement the first generation of ELT instruments. This indeed was some ISO programmatic and strategic requirements. So we were really asked, we've been asked to have instruments that were complementing each other. So MOSAIC will be the instrument with the highest survey speed, thanks to its multiplex and wavelength coverage. It will also be the instrument that will go bluer as well as iris, but it will not have the KE band indeed. And also it is requested that it will be able to function in all seeing conditions. Then what is important about MOSAIC is that with its MOS and multi-object IFUs will be the only at the horizon of the 2030s. And of course, the science that can be performed goes from first galaxies, galactic science, large-scale structure, galaxy assembly, AGN and galaxy coevolution, resolved stellar population behind the local group. So it's really a multitasker instrument. Here, I present you the MOSAIC science drivers. Actually, we'll present you just the 5-dimensioning science cases, which means the science, the specification, the design of the instrument. So they are first light galaxies and reionisation. Then there is the inventory of matter, mass assembly of galaxy through cosmic time, stellar population beyond the local group, and galaxy. To this 5 science case, we are also adding now something about something new about transient, and all of this is actually described, but also there is some papers on potential surveys. Why do I mention surveys? But first of all, because as I said before, will be the only instrument on the ELT with MOS capabilities, with high multiplex capabilities, and also because the MOSAIC Consortium is actually made by 3 main partners, that is France, UK, Netherlands, and Germany, to which we add Austria, Brazil, Finland, Italy, Portugal, Spain, Switzerland, Sweden, University of Michigan, and STSCI. And the reason is that the consortium is responsible for raising the complete construction and the commissioning funding of the instrument, including contingencies and funding costs. For you to have an idea, we are at the level of something 90 million euros, adding FTEs plus hardware costs. So it's quite expensive instruments. To raise all this money is not as simple as that. You know, Mavis just mentioned before, they miss 4 million. But as a rewards, we will get 125 nights of GTO on the ELT. And what is extremely important is that the consortium just decided to pull all these nights, and in order to have surveys that actually will be performed in the interest of the whole consortium. So if I now go through some of the science cases, of course, I will not have time to discuss them all, so I will just touch the extragalactic ones. So what do we know about the first light galaxy and the reionization today is limited by the capabilities of today's instrument. So, for example, we know that galaxy at a redshift around higher than 7 starts to lose their the capabilities to detect Lyman alpha to have Lyman alpha in emission, but then on the other hand, we are not able to detect the rest frame continuum. So here situation, because as you can see here in the simulation, for a redshift 10 candidates at J29, we can actually be able to detect Lyman alpha in emission with the IFU. But of course,
5 minutes.
This is where JWST will actually work, and the synergy is actually really high because we will JWST faint sources, as you can see here, where you see the absorption features. But here in the simulation, instead, what you can see is how the power of the multi-IFU with respect to the MOS, where for an object at redshift 8, AB27, we can easily detect all these nice absorption features with 30 hours of integration, thanks to the very accurate sky subtraction accuracy, but also to the fact that with the IFU we will have a larger collecting area. Another science case that might be of high interest is the inventory of matter. So here we want to study scale, not only dark matter, but also the gas. And this can be done with MOSAIC, of course. And as you can see, a very hot topic today, because there has been studies, recent studies of high redshift galaxies that seems to be dominated by baryonic matter at high redshift. But of course, these results is still debated because other groups found different results. And with MOSAIC, we will indeed be able to resolve the velocity fields of these redshift galaxies high redshift galaxy in the range between 2 and 4, function of the galaxy mass, to compare these results with simulation and to really constrain models of galaxy formation and evolution. For doing this kind of analysis, for example, we know that we needed to reach, to be able to reach a high signal to noise ratio in the outer part of the galaxy, to be able to have an unbiased rotation curves for this individual galaxy. And indeed, this will be obtained by using field of view of the order greater than 2.5 arc-second and with a resolution of 120 mass per spaxel. That is what we are actually doing with MOSAIC. Again, we can also study the MOSAIC will enable to map the distribution of cold gas at redshift around 3.5 on megaparsec scale, using the Lyman alpha forest, the Lyman alpha emitters on the foreground of galaxies. And this by using the high multiplex mode in the visible. As I mentioned before, what is important for ESO is also that MOSAIC will complement other instruments. And so in the IFU, we have a direct comparison with Harmony. So Harmony will really win over MOSAIC for point sources, despite the multiplex of MOSAIC. And the reason is that Harmony Maybe just let me say that the consortium is still organizing itself, and so if there are people interested in joining the science team, just drop me an email. And otherwise, I mean, what I can say is that the MOSAIC in the 2030 landscape appears like an instrument that will excel at deep pencil beam surveys of faint sources, complementary to ELT instruments. And what I think is really important is that it will open a large discovery space for any science case where the statistics play a key role. So somehow on the, I can imagine that the MOSAIC on the ELT will play a similar role to what VIMOS did on the VLT. And so thank you all for your attention.